In this session, we're going to walk through creating access lists on Arista switches. Access lists are most often associated with security and quality of service, while prefix lists are generally used to select or block certain routes within route announcements or route redistribution. Both can be called and applied in many ways and in several locations of the switch configuration. For both access lists and prefix lists, the lists are processed in a top-down manner. In other words, they are processed in order, beginning with the first rule at the top of the list and proceeding down until a match is found. Access lists, also referred to as ACLs, are a flexible way to identify traffic to which an action can be applied. ACLs can be written to match on a variety of information, including MAC addresses, IP addresses, TCP port numbers, and UDP port numbers. ACLs on Arista switches support both IPv4 and IPv6 addresses. The full list of ACL types that Arista currently supports is IPv4, IPv6, standard IPv4, standard IPv6, and MAC. ACLs can be used for control plane policing, interface control, identifying packets for use within quality of service, and called by route maps. For example, for the cases where an ACL applied to an interface, the flow will be as follows. When a packet arrives on an interface that has an ACL applied, fields within that packet are compared to the rules in the ACL. The first rule is checked, and if the packet matches that rule, the packet will be forwarded or dropped, depending on the action of the rule being either permit or deny. If the fields of the packet do not match the first rule in the ACL, then the packet is compared against the second rule of the same ACL. This iteration continues down the ACL in sequential order until either the packet matches one of the rules and is permitted or denied, or we get to the end of the ACL without a match, in which case the packet gets dropped. The match criteria of an access list can key against multiple fields of an IP packet. If we attempt to match against multiple fields in a single line of an ACL, then all the fields must match. Let's take a look at an IPv4 access list. On switch 1 in my lab, I created an access list called foo. So if we issue the command show IP access-list, enter, we can see there's a default read-only access list already there, the default control plane ACL. But underneath that, we can see the access list I created called foo. You can see that this access list has two lines. The first line permits a specific host to talk to another specific host via TCP port 80 or www, which is the HTTP keyword. The second line denies the same source host IP address from talking HTTPS to the same destination. Let's walk through the steps of creating an access list. From here, we would type config, enter, and then we could type IP access-list space question mark. We see our options are to provide a name or to create a standard ACL. Let's provide a name and call it example 1. Enter. Now, if we issue a question mark here, we notice there are several options such as permit, deny, remark, and even the option to insert sequence numbers. If we don't specify a sequence number, the switch will assign one for us, starting at 10 and then increasing upwards in increments of 10. So now if we type permit question mark, we can see several options, including specifying if this is related to TCP or UDP fields of an IPv4 packet, or we can match on other criteria such as OSPF, PIM, a specific IP protocol number, or others. Let's do a permit TCP. Type TCP space question mark. This is where we're going to enter the source. Can be a source network or subnet, a specific host, or we can simply say any, in other words, all. So let's add a source subnet, 10.11.11.0/24, and hit question mark again. Next, we can enter our destination host or subnet, or we can specifically call out the source port. But since source ports are usually ephemeral, I don't use that option very often. Let's add a destination subnet of 11.10.10.0/24 and issue another question mark. Here we see several matching options, such as using the EQ keyword, which stands for equals and is used in this case since we're creating a TCP-based line for this ACL. We could reference a specific TCP port. So let's use the equal option and then another question mark. EQ space question mark. As you can see in the output, there are a bunch of keywords we can take advantage of. Or we can simply type the exact port if we know the exact port number, or use a specific keyword if one is available for us. Let's say we want to permit telnet from 10.11.11.0 to network 11.10.10.0. So I'm going to type in telnet here and hit enter. Now, if we stop here and type exit, we can issue the command show IP access -list and hit enter. And we can see our example one that was created, where we have a sequence number of 10 that permits TCP from 10.11.11.0/24 to 11.10.10.0/24 as long as the destination port is telnet. Notice that the sequence number 10 was inserted for us by default. And also notice how simple it was to use the CIDR notation or the /24 rather than having to fully type out a subnet mask. So let's get back into configuration mode of that ACL and add another line to it. IP access -list example 1, enter. And now let's add a UDP statement. So let's do a permit UDP, and we use the same subnets, 10.11.11.0/24 with the destination subnet of 11.10.10.0/24. And we'll have it equal this time UDP port 53. And then let's add one more line to that. Let's add a permit IP any or a catch-all line at the bottom. Not that you would necessarily do it this way in a production network, but just to simply show that we can do it and what the resulting ACL will look like. We'll type permit IP any, enter. Now, if we type exit, we can look at all of our access lists with the show IP access -list, or just simply focus on this examples, show IP access -list example 1, enter. We can see our newly added lines and that the switch automatically inserted the sequence numbers 20 and 30 for us. Now that we have an access list, let's apply it to an interface. From config mode, let's apply this ACL to our Ethernet interface 5. So let's go into interface configuration for Ethernet 5. So it's interface Ethernet 5, enter. And then the command to call an ACL for this interface is IP access-group. If we enter a question mark, it's asking us for the name. Type example 1 space and then a question mark again, and we can see that our ACL can be applied in for inbound packets or out for outbound packets. So we can just issue enter and then issue the command show run interface Ethernet 5. And we can see our IP access group example 1 supplied to that interface for inbound packets. Now every packet entering that interface will be subject to inspection against each line of our access list looking for a match. In this specific case, since I added a line for permit IP any at the bottom, if we don't have a match in the first two lines of the ACL, the packet will be permitted by that catch-all IP any. But what if I wanted to add a line but not place it at the end of the ACL, rather in the first position or second position of the ACL? We can leverage the ACL sequence numbers to insert permit or deny statements amongst existing ACL rules. Let's add a rule as line 15 to our example 1 access list. So again, let's enter IP access -list example 1, enter. And then now let's put a sequence number in, the number 15 space, and then we'll permit another TCP statement. So let's do permit TCP from our 10.11.11.0/24 subnet going to our 11.10.10.0/24 subnet. And let's have it equal, this time SSH, and hit enter. Now if we type exit, that line of the ACL is updated, and we can issue the command show IP access dash list example, enter. And now we see we have a new line inserted as sequence number 15 for our SSH keyword. Now suppose that I don't really want that new line. Do I have to delete the whole ACL and start over? No. We can simply remove line number 15. So get back into the configuration of the ACL, IP access dash list example 1, enter, and just simply type no 15, enter. Exit, and then reissue the command show IP access dash list example, enter. And we can see now that our once added sequence number 15 specific for SSH is gone. And we're back to our original 10, 20, and 30. As another example, what if I wanted to increase all the sequence numbers of an existing ACL because I know I'm going to need to add some more specific rules at the top or the start of an existing ACL? Should I just start all over again? Well, you don't have to. The resequence command is a way for us to renumber our rules and supports us deciding what the increment value should be as well. So let's resequence our ACL example 1. Let's have it start with 200 and increment by 20s. Go back into configuration of that access list, IP access dash list example 1, enter, and then we use the resequence command. Resequence, we can do a space question mark, and we see we have the option for the starting sequence number, which defaults to 10. So let's put in here 200 and then another question mark. And we have the option to include the step to increment the sequence numbers, which again is default of 10. Let's put in 20. Hit enter, type exit so that our changes are applied. And now reissue the command show IP access dash list example 1, enter. And we see our sequence numbers have changed. Now we have 200, 220, and 240. We resequenced starting with 200 and then increase the increment from the default of 10 to now a default of 20 for each step specific to that ACL. At the outset, we mentioned that ACLs are not only used for security reasons. Sometimes we leverage ACLs to identify packets for other features. A good example is quality of service. Let's create an example quality of service class map and associate our new ACL to that class map. From config mode, we'll type class-map, and here we'll just have it match any, so match-any, and then we need to name it. Let's just call it the same name as we called our ACL, example 1, enter. And now we're in class map configuration mode. So if we type match question mark, we see that we can specify an IP access group or an IPv6 access group to match on. If we type IP space question mark, now the keyword access dash group, and then another question mark shows us that we need the name of the ACL. So we'll put in our example 1 and hit enter. If we exit that and type show class dash map, we see that our example 1 class map that matches any is now calling the access group example 1, which is the ACL that we had created. We also mentioned that ACLs can be referenced by route maps. Let's create a route map called example 1 and associate our ACL to it. Here in configuration mode, we'll type route-map space, let's call this example 1 space, and then with the route map, we need to put in stanzas. So let's do a permit 10, enter. And now question mark here shows us we have the option to match or to set amongst some others. So let's type match space question mark, and we have all kinds of criteria we can match on. We're going to type in match space IP space question mark, and now we see we can match on an IP address, a route next hop, or a route resolved next hop. So with the IP option, if we type in the keyword address and hit question mark, we see we have the option for either an access list or a prefix list. So if we type in the keyword access-list and one more question mark, and we can see it's asking us for the specific access list name. Here we'll type our example 1, enter. If we get out of route map configuration and simply type show route-map and hit enter, we can see our route map example 1 and then our match IP access list example 1. Now we have examples of calling our ACL both within class maps for things like QoS or route maps. In summary, ACLs can be used on Arista switches for a variety of reasons, including security, quality of service, called by route maps, and several other areas of our configuration. Be sure to read Arista's configuration guide to get more information on configuring ACLs.